Hello all, today we are discussing on the time period and height of building or the seismic analysis. In the earthquake prone zone, seismic analysis is important for any structures. While doing analysis, there are two factors, that time period and height of building. One should take in considerations carefully. So let we begin with the time periods. A time period means the time of one complete cycle of oscillation, that is one complete back-end earth motion, and it is also known as the fundamental natural period. And the time period depends upon the flexibility and the mass of the structures. So as you can see in this slide, there is a formula T equal to that K into S of 3 by 4. That means the K is depend upon different types of structural systems, and the value of K is given accordingly for the different types of structural systems. And if we, while doing analysis as per the structural system, we need to take value of K, where H is the height of buildings from the base or foundation to the uppermost portion of buildings. But the height of building for any structures, how to take, there is question mark, and the Nepal stand code is not clearly mentioned about the height of building for different type of structures or different category of structures. There are so many other countries, they clearly mentions about the height of building, but as per Indian standard codes, we can see, and Indian standard codes clearly mention about the height of buildings for the different structures. As you can see in the first figure, the height of building is taken from the base or the top of the rigid basement to the major portion of the roof, that is height, and the foundation or basement is open to the atmosphere. So in the second figure, you can see that the height is taken from the upper portions, that is excluded the infill wall portion. If there is an infill that acts as a rigid structures or rigid elements, so the height is taken from that excluded portion of the floor to the top of the main portion of it. Similarly, if there is any basement, you should take the height from the ground levels to the top of the main roof. And similarly, there are two major structures. That's strip-back buildings. You can see that weighted mean height is taken as such conditions. Then you manually do the analysis for the seismic force or base. As you can see that there is formula for the H, and A is the area of that particular floors, and height, HI means that height of particular floors. And similarly, you can get all the parameters from the structure itself, and you get the weighted mean height, that is X. And we should know about the height while we construct any structure in the sloping grounds. For such condition, we need to take the height from the upper the top of a main roof. You can see in the IS code. For example, you can see I have already modeled one structure, that is the step-back buildings, setback buildings, these two close setback. So while taking the height of buildings for the seismic analysis from that particular formula earlier mentioned, if it's an 18 meters height of buildings, then it may come around 9.01 meters. So the height of building is only 90 meters. For analysis, you can use any software, in particular ETABS. There is the toolbar, and you have to define the load patterns. While doing so, the seismic load patterns, we need to mention their time period. Time period coming from the height at 9 meters for a special moment resisting frame, we can achieve this value, that this particular model is the special moment resisting frame. And while providing the story range, we need to provide that bottom story to top story, and within the particular 9 meters height, how many floors included, we should mention in this. If there is any infill, we excluded that infill portion. Normally we take from the without infill portion to the top of a major roof floor. While in this case there is no any infill wall, we directly take from the ground floor levels to the third floor, that is 9 meters. So the time period is important factors, because of time periods directly affect the analysis of the structure. It increases or reduces the seismic forces, greater the flexibility, that is greater and longer the time periods, which means that if the time period is more, there is definitely more the basis, and similarly the mass of the structures is large, that means the longer the time period. So while doing analysis of any structures in the ETABS or any other softwares, we must know about the provisions, total provisions, and accordingly we take the height for seismic analysis, so that our design or analysis becomes more rigorous or economical. Thank you so much for watching. Please like my videos, subscribe my channel. Thank you. Have a nice day.